One of the questions that has bugged our species since the evolution of enhanced sentience in the art of philosophy. One of the subjects that has been sought after by scientists, filmmakers, and documentarians alike. That idea with which our species racks its collective brain over to come up with a believable and hopeful conclusion to is whether or not we are alone in the universe.
Ask the Guild.
Extraterrestrial life has been a heavily studied subject since the very beginning of astronomy, with the invention of stronger and more specific telescopes by the likes of Hans Lippershey, Galileo Galilei, and Johannes Kepler. Even before this, humans have been looking up to the stars and wondering a great many existential things. Who are we? Where did we come from? Are we alone? This time on Ask the Guild, we answer the question, has there been any proof of life in space? And, dear viewers, the complex and charismatic answer to this age-old question, an answer that has been sought after by the world's greatest scientists, mathematicians, and philosophers is... nope. Pretty much jack squat. Okay. There's more to this question than meets the eye, and we thank Crookhook for asking it, so let's get into it a bit more. Earth. A floating ball of water, air, and Earth is a planet that lives snugly within our solar system. As far as we know, it is unique, for it is a harbor for the only forms of life we know of. All life forms on Earth are carbon-based, and have evolved over hundreds of millions of years, over limitless generations to arrive at their present state. However, what about life elsewhere in the cosmos? To date, there is zero evidence of life anywhere other than on planet Earth. However, surely with the billions and possibly trillions of planetary bodies in existence, there must statistically be some form of life elsewhere. One such statistical probability lies in the Drake equation, which is as follows. The number of civilizations n is assumed to be equal to the mathematical product of r, average rate of star formations in our galaxy, Fp, the fraction of formed stars that have planets, Ne, for stars that have planets, the average number of planets that can potentially support life, Fl, the fraction of those planets that actually develop life, Fi, the fraction of planets bearing life on which intelligent, civilized life has developed, Fc, the fraction of these civilizations that have developed communications that release detectable signs into space, and L, the length of time over which such civilizations release detectable signals, for a combined expression of n equals r times fp times ne times fl times fi times fc times l. However, the criticism given to this equation focuses not on the equation itself, but on the fact that the estimated values for several of its factors are highly conjectural, the combined effect being that the uncertainty associated with any derived value is so large that the equation cannot be used to draw firm conclusions. So basically, there are so many planetary bodies that it's likely to be statistically impossible that there are not at least one planetary body other than our own within the universe, or even within the Milky Way galaxy, that harbors some form of extraterrestrial life. And this is just referring to life as we know it, that is, carbon-based life. As far as we know, there is only carbon-based life, and life needs this element to exist. However, that is not necessarily all there is, or ever will be, for other elements could be used for the explosion of new life forms in other places. Silicon-based, hydrogen-based, or even something as radical as arsenic-based life forms are theoretically possible, though more implausible, for the carbon atom is one of the more versatile elements. Even on other planets, it is unlikely that carbon would be replaced for the simple building blocks of life, for it has rather unique characteristics, one of which is the ability to form 4 strong chemical bonds within other atoms, including other carbon atoms. Carbon can form more compounds than all other elements combined, making more unlikely that life on other planets would utilize other elements when carbon is the more efficient, easier element being used as the basic building block of life. Life on Earth changes over time through the process of natural selection via evolution, and this simple natural process would not be exclusive to our planet if other life forms were to emerge elsewhere. This concept has been taken to great extremes by many artists and scientists to help speculate on what life forms could have evolved on other planets that could statistically harbor life, whether they are similar or different from our own. Visionary artist Wayne Barlow has produced many pieces of hypothetical extraterrestrial life forms, which have proven so lifelike and believable that a mockumentary was produced entitled Alien Planet, in which the organisms and ecosystems envisioned by Barlow are brought to life via computer-generated special effects. Life on other planets would have evolved completely isolated from any cycles life on Earth went through, therefore making any depiction of extraterrestrial life that appears anything like what we have on Earth today or in our past is completely illogical and scientifically implausible. Another project into the world of speculative extraterrestrial evolution is the SNIAD project by artist C.M. Kozman. In this exercise, he has imagined a world in which life has sprouted in a very different way to our own. There you have it. The universe is a strange and beautiful place, and we are only but a speck compared to what there is. There is most certainly life out there in the cosmos, but what it is, and exactly what it looks like, is a mystery, and may forever remain a mystery. But that does not stop us from searching, speculating, and experimenting, for we are curious creatures among many on the beautiful blue marvel spiraling out of control in this never-ending place we call the universe. Thanks for watching. This has been Ask the Guild. We ask you to put your questions in the comment sections below, for it may be turned into a video just like this one. Make sure you more or less keep it within the life and earth sciences.